One of the most common applications for an exponential function is that of compound interest. So compound interest is something we use in finance, and even though we sometimes, even I forget that it's an exponential function, when you look at the compound interest formula, it is an exponential function. So you've had compound interest before. So let's say we have for n compounds per year. So we would have A equals P times 1 plus R over N raised to the NT power. Okay, so to kind of review this formula, A is our future amount. P, normally we call it principal amount, but I will just call it an initial amount. R is our annual interest rate. T is time in years. And N is the number of compounds. Per year. Okay, so I want to focus on our N. So if we have annual compounding, N is 1 because we only compound once a year. If we have quarterly, N is 4 because there are 4 quarters in a year, so we compound it 4 times. If N is monthly, we compound 12 times a year. And we can go on to daily. Which N is 365 days a year. Okay, so notice that we're getting more and more compounds. So now the next thing we're going to look at is, well, what happens if the number of compounds keep on going up? Like let's say we do it hourly, or every minute, or every second. We compound every second, or we compound every millisecond. And so at some point, you keep on thinking, well, we're actually compounding, infinitely many times in a year. Or what we say is we are continuously compound. So for number 2, for continuous compounding. So if we have continuous compounding, what happens is, this equation here, the n's start going to basically infinity. They keep on getting bigger and bigger. And this equation turns into A equals P e to the RT. Alright, so A is still our future amount, P is still our principal or initial amount, R is still the annual interest rate, and T is still the number of years. But we end up having this E, and this E, that natural number, then has us compounding continuously. So let's look at an example of using this. You invest $3,000 in an account that earns 11% interest compounded. Let's start off with quarterly. how much is in the account after 5 years. Okay, so because it's quarterly, we need to put in A equals P times 1 plus R over N to the NT. Okay, so our principal is 3,000. 1 plus R is 11%. Now remember, you have to write the percent as a decimal. N, we're quarterly, so quarterly is 4. And we have 4 times 5. Now, look what happens here. Let's see, 0.11 divided by 4. So notice that 0.11 divided by 4 is 0.0275, and we add 1, and that becomes 1.0275. So we end up with 3,000 times 1.0275 raised to the 20th power. And so we do have the basic form of an exponential function. We have a, b. Now, usually this is an x, but we are evaluating it at one specific point, 5 years. So we do have 20 up here, but it is an exponential function. All right, so let's see what we end up with. So we're going to take that 1.0275. Notice it's still my calculator. I didn't erase that. And then I raise it to the 20th power, and I multiply that by 3,000. And we end up with $5,161.29. You know, when we're working with money, of course, we use a little bit of logic. You don't go to 4 decimal places because we don't have any form of currency that goes to 4 decimal places. So we just go to the normal cent and round off. Okay, let's try this part of the problem. What if we compound continuously? So, part B, complete the same situation for continuous compounding. Okay, so this is A equals P, e to the RT. So then this is 3,000 times E raised to the 0.11 times 5. So 3,000 is our principal or initial amount. We have our number E, and then we're raising that to the R. R is 11% or 0.11, and then 5. So let's try that one. So I'm going to take E and raise that to the 0.11 times 5, and then multiply that by 3,000. And so we get $5,199.76. All right. Now, what this does is it gives us our limiting factor on compounding. Because a lot of people think that, well, if you keep on compounding more and more and more, there should come a point where you just keep on making more and more and more money, and it seems limitless. Because if you think, oh, I'm compounding every millisecond, that should give me a lot of money. But because of the way compound interest works, it really doesn't. There is a limiting factor. So no matter what, the most you could ever get out of this situation of 3,000, 11% in 5 years is $5,199.76. no matter how much you compound. You know, if you want more money than that at the end, either A, you have to raise your interest rate, B, invest for longer, or C, increase the amount you initially invest. So, but increasing the amount of compounding isn't going to get you very far. Okay, so there you go. There's a nice review of compound interest. We then looked at something called continuous compounding, and that's where this compound interest formula turns into this A equals PE to the RT, and then we did a couple of examples using that.